Hello everyone. In this episode we're going to be looking at how we can take the integral of cotangent to the fifth x, cosecant to the fifth x dx. So for this one, we need to remember our rules here for the cotangent cosecant integration by part rule. We remember that if cotangent is odd, we strip off a cosecant cotangent. But if cosecant is even, we strip off a cosecant squared of x. And you can notice here that cosecant is odd, but cotangent is odd. So using that knowledge, we're going to use the rule that we have to strip off a cosecant cotangent x. Okay, and when we do this, we're going to notice that we're going to get a Pythagorean identity of cotangent squared x, and that will equal cosecant squared x minus 1. So let's actually show what that actually means. So I'll go ahead and rewrite the integral as a similar idea. So we're going to say that we're going to strip off a cotangent. So give me just 1 second here. So we have cotangent to the fourth x, and we're going to strip off a cosecant and a cotangent. So we have, now we're going to have cosecant to an even power, right? And then that's going to be multiplied by cotangent of x, cosecant of x. And that's and we're taking the integral with respect to x. Okay, so we have this idea here, and we know that if we take the integral of cosecant, we're going to get this piece here, the cotangent and the cosecant of x, right? That's just a simple identity that we've discussed, that when you take the derivative of this, we get cotangent, cosecant. So knowing this, we're going to actually use this as kind of a leverage. But first, we need to get rid of this, right? Because when we take the integral of a cosecant, we do not get cotangent to the fourth of x. And there's a simple way that we can get cosecant for x in terms of, cotangent for x in terms of cosecant for x. And to do that, we're going to use that identity of cotangent squared of x equals cosecant squared minus 1. So I'll write that out quick. And notice how it's to the fourth power, so we're going to square the entire thing. So cotangent, we know that cotangent squared, so if that power was 2, it would equal this. So cosecant squared of x minus 1. We're going to, since it's to the power of 4, and this identity is with respect to the power of 2, we're going to square the whole thing by a square. And remember, we're taking the integral, so don't forget your parts here. And we're going to take that multiplied by cosecant for x. So I want you to notice as I'm writing this out that we have everything in respects of cosecant of x. And we know that the integral of cosecant of x is cotangent cosecant of x. So this is going to allow us to do some u sub. Now that we have the two inverse parts, right, to this, we can go ahead and take the integral with u sub. So I'll show you how to do the u sub. It's not too difficult. Cosecant of x dx. Okay, so the u sub here, we need to identify what is u and what is our du. So our u here, remember we said we take the derivative of this, we get cotangent cosecant, right? That's just on your, hopefully you've been given a reference sheet. If you look at just the common integrals, the common derivatives, cosecant of x derivative is cotangent cosecant. So u here is just going to be cosecant of x, right? So we can put u to respect to some power, right? So this would be u to the fourth here. And we know that du is equal to negative cosecant cotangent. So notice how we have these two here. We have u, and we have all of that here, so we're going to have to do some u here, and we need to put dx here as well. Don't forget that. du here is with respect to this term. So let's rewrite that. So we're going to say that the integral of u squared, right, because that's cosecant squared, and u is equal to 1 cosecant, minus 1. We're going to square that, and now it's cosecant, or sorry, not cosecant, geez. We're doing u sub, u to the 4th, and then that's going to be times du. So we take the integral of u with respect to du, or we take the integral with respect to u. So now this is just some simple little algebra, and then we can do a substitution after we take the integral. We're going to have to first FOIL this, and then distribute our u to the 4th. So let's FOIL out the u squared minus 1. That's going to be u 4th, right? Hopefully you're pretty good at FOILing at this point. Minus 2u squared plus 1, right? And that's going to be all times u to the 4th. And remember, we need to put du. Okay, so here we have this, and now we just need to distribute in our u to the 4th. Okay, so let's go ahead and do that. So this will be u to the 8th minus 2u to the 6th plus u to the 4th du. Okay, so this has been quite the journey so far, but now we're at the end, basically. Just don't forget to actually take the integral of u. So remember, it's just that simple inverse power rule idea. So we're going to say that u to the 9th power 1 over 9, right? Because we take the integral of this by the power rule, bring down the exponent, that cancels out to 1, u to the 8th. So we get this when we take the derivative. So you know that you did it right. This is going to be 2 over 7. Oh, and one more thing. I almost forgot. Notice how du here is not equal to this term here. We have a negative cosecant cotangent x, but this is just cotangent cosecant of x, and there's no negative sign. We actually need to bring that out in front. So sorry about that, but right. So we bring the negative out, and when we actually do this part, we're going to distribute that negative to each. So it would be negative 1/9 u to the 9th plus this term here, and then minus 1/5 u to the 5th. I apologize about that. But yeah, this is our integral with respect to u. Now we just need to plug in what u is, and this will be equivalent to our overall integral here. So let's go ahead and do that. Okie dokie. So that's a lot of writing, but that is the overall integral. Sorry, I made that mistake earlier where I didn't point out that this negative needed to come out front. But yeah, so the integral of cotangent 5x cosecant 5x with respect to x. We know that a cotangent is odd, and given that rule, we know that we have to strip off a cosecant cotangent. Right, then we're able to do the Pythagorean identity. Here we take u sub, and we simply get our overall equation here, which is this here. So hope you guys enjoyed. If you did, please drop a like, subscribe, do anything to support. I'd really appreciate it, and have a wonderful day.